My name is Igor Artamonov, and I'm going to talk about blockchain, Ethereum blockchain, and IoT. And this title I figured out, I think, like yesterday, answering questions what I'm going to talk about. I'm going to talk about smart contracts not for humans, but maybe for robots or something. And yeah, you'll see what I mean. It's kind of controversial topic, actually, and I just want to start discussion and, I don't know, give you something to think about. So yeah, my name is Igor Artamonov. I'm a software engineer, like 15 years of professional experience, 10 years hobby before, and so on. And I'm one of the developers of behind Ethereum Classic blockchain. When this fork happened, Ethereum ETH, Ethereum ETC, we split into two different blockchains now. And then I founded ETC Dev Team, which is leading company behind Ethereum Classic development, but there are a few other companies. I'm not going to talk about ETC or ETH, but about Ethereum in general. So, about blockchain, smart contracts, and IoT. It's a broad term. I'm not expert maybe in IoT, and not in smart contracts even, so I'm developer for all this stuff, but I'm going to give you some my opinion on all these topics. So let's start with a smart contract. And who knows what is smart contract? Who like brought some code, something before? Anyway, yeah, I'm going to give some example, just basic example of token, right? Token is some function on blockchain that provides you basically two functions. It's very simplified version of smart contract, right? So you have a balance and you can transfer balance from one account to another account. That's it. And yeah, it looks like this. You have transaction when user A said, I want to transfer 15 of something, 15 tokens to user B. You have a blockchain state, all this stored in blockchain, key value database, kind of. And you have some smart contract, which execute the following operation in the middle. It's plus 15 to one account, minus 15 from another account, or opposite. And you got a new state. That's basically token, ERC20 token, maybe. This is an example of that. It's actual code from Zeppelin that most of ERC20 tokens use. It's basically the same as I said before. You see there's some verification initially, then you add balance and decrease balance, add balance to another account. And that's it. It's a very simple function. It's just execute on blockchain and against data stored on blockchain. Right? It doesn't have any UI, it doesn't have external dependencies, only blockchain, only data. And there is some formal definition of smart contracts, which is defined more than 20 years ago. Smart contract is a computer protocol intended to digitally facilitate, verify, or enforce the negotiation or performance of a contract. I read somewhere that initial example was actually this vending machine that when you put your money and you get a bottle of soda. That's a smart contract. That's agreement between you and machine what it will do. Yeah, legal agreement maybe because you spend some money and receive some result. So I'm going to give some examples of legal smart contract. In my opinion, legal. Can be called legal. So it can be some token, one example, another one is insurance. I just heard this example many times, like, I don't know, your car crashed into another car, and you have both had some smart contract, and all payments and everything was processed through the smart contract. My point that, okay, yeah, you can have this smart contract on blockchain for insurance or whatever, but why? you have people, you can communicate to each other without smart contract. You can have this on paper. You can decide, make decisions without any smart contract. Why you need smart contract at all for this case? And the tokens I spoke before. Yeah, that's a legal smart contract too, because you send in some digital assets, some money maybe. But let's look at real code of smart contracts. This code I took from one of the top 5, I think, UC20 tokens on Ethereum ETH blockchain. That's actual code from their GitHub. If you look carefully, you see that the owners of the smart contract can stop it at any moment of time on their sole decision. They think something goes wrong. And it's common for many tokens. Or there are other examples. There is a way of changing, upgrading smart contracts. So there's a person who decides how it's going to work, not a smart contract. So it's not like in a paper when you, it's people decision. It's not smart contract decision. It does make sense. I don't know why you would use a smart contract which is pausable or replaceable or whatever. It has nothing with reality, because at any moment you can expect that rules will be changed by some one decision. So you can't rely on this code and deploy it on blockchain anyway. And the problem that most people, because of this definition and because of a lot of discussions around tokens and everything, most people understand that it's some legal agreement. But in fact, it's just a code deployed on blockchain, and you shouldn't make any legal bindings based on this code. And it's usually not enforceable. It's not agreement at all. It's just something working on blockchain. And the term contract itself, at least in English language, for most people, I talk about smart contract, they see contract as something written by lawyers. That's, I don't know, by definition, I guess, that's some language problem. I mean, for me, it's not a contract, because difference in language. Anyway, so most people understand that it's something legal. So it's really hard to talk to people and discuss something unrelated to digital assets, to tokens, or some ownership on blockchain. It's always about this stuff. And I think it's just wrong terminology because of this content. And I heard that in IBM Hyperledger, they use a different term called chain code, which may be better for this kind of functionality. So my point that maybe it's not for humans. Maybe we can work on just paper contracts. Do you really need a smart contract deployed on blockchain for anything? I don't know. Maybe no. Maybe it works better for machines which don't have other way currently to communicate with, to make settlements, make agreements, not legal agreements. They need some formal way of making agreements. And it can be robotics, it can be autonomous cars, it can be home automation. And I want to give some examples or explain why I think so. And first of all, it's because of Ethereum virtual machine. Because I think it can do this job of making settlements between machines. And some introduction to the history, actually. So Ethereum virtual machine is not the first virtual machine designed that can be used for these things. The first one was designed for IoT. It was in the 90s, and it was called Java virtual machine and Java language. The point was that write once, run anywhere, because many different operating systems, and it was designed for some smart devices. There is no IoT, no smart devices back in the 90s, so they switched then to applets, and then to server-side programming. And it worked fine for them because it still works. It's a most popular language for enterprise development because of this difference, initial at least, because of the difference in operation systems and hardware and everything. It was really hard to write code on, I don't know, C, CBP, and in Java. You just compile it in your machine and using Windows and deploy to some server using Linux. And it works. But unfortunately, it didn't work really well. And there is some phrase, like phrase of this write-ons run anywhere. It's debug anywhere, everywhere. And there's a lot of issues. Anyway, anyone has experience with Java, deploying enterprise environments and everything? Me too. I spent most of my time on Java, doing some consulting and everything. And there are many different issues, not with Java itself, but with environment mostly. And yeah, I can give you many examples, but I give you just one because I think most of you never faced this issue. And I guess you see from my accent, I'm not from the United States, so I'm from Russia, from Siberia. It's like in the middle of Russia. It's opposite from Atlanta. And it's like 10 or 11 hours difference, time zones. And sorry, I said 10 or 11 hours difference because it depends, summertime or winter time, and so on. So there's time difference between time zone difference between countries. And when you develop in one time zone and deploy into another time zone, at least 15 years ago, it was a huge issue. I spent so many nights, again, nights, because it was night on my city and day here. The code didn't work well because of some problems with time zones. For example, you wrote some code, compiled it, deployed to a server, but for this server located here in the United States, it's a future. It can be cached, it can be used really because it's called from future from 10 hours after this moment of this machine, and it does work. It's really hard to figure out why it doesn't work. Yeah, now it may be easier because of clouds and everything. You're using UTC time zone everywhere, but back then, like server was someone's computer. Someone went to Best Buy, bought a physical computer, brought it home, installed operation system using his local time zone, Eastern Standard Time Zone, and said it's a server now. I use different time zone, so that led to many problems. So I don't know, many people, including me, thinking that there is 24 hours in a day, which is not true because we have time shift sometimes in 23 hours, sometimes 25 hours in a day. And in these days, the application just crashes, it doesn't work. And you can't explain that because something went wrong and it's impossible to figure out. So that's one of the issues, and there are many similar issues, each independent from virtual machine itself, but that's a problem of having different locations, different hardware, different operation systems, and everything. So now back to Ethereum virtual machine. There is no time zone in EVM. Nothing at all, so no problem. It's eliminated. So you can use it anywhere, in any city, in any planet, in any galactic, and it will be same time zone. I mean, there is no time zone at all. So you can make this kind of mistake. There is no file system. Again, there are a lot of issues with file systems in different operation systems, different versions of operation systems. And I don't know how many time I spent on fixing these issues in a program. Again, it's not EVM issue, but it's an issue with environment. So it's eliminated in EVM again. You don't have access to file system at all. It's isolated. And it's also isolated from the network. So there's nothing that can affect your execution. You can't get anything, including random values. There is no random values. That's kind of issue, actually. For many applications, you need random values, some source of random values for encryption, for example, for gambling, whatever. And yeah, there is no random values, which is bad maybe for some developers, but it's good that you can make a program that will do something unpredictable. And there is also no floating point numbers. It's another issue with all operation systems and different hardware. And even the order of your variables, if you put them in different order, you can get different results because of floating point numbers, decimals, how it's usually calculated. So in EVM, you have only 256-bit numbers, like big num or something in Java. So with all these limitations, I think it makes sense to use EVM unrelated to blockchain, just EVM, to build some systems, and you can make better systems or reach better goals, much something bigger than current operation system or anything for EVM, and that's because of limitation. It's very common in engineering. I think there's some physical explanation maybe for this, that if you limit it in all directions and have just only one direction, you'll reach much bigger goals. And yeah, there's a lot of examples in engineering about this, in software engineering, like how you make scalable systems or whatever. Yes, again, you can make scalable system if you limit yourself from file system, from memory and everything. If you have this empirical application, like Google App Engine, for example, you can make it scalable really easily. So, virtual machine is more close to mathematical function. So the code which is executed on this virtual machine will provide the same result for same inputs on any hardware, on any place in the world or in space, anywhere. It's fully isolated. You don't have access to file system, to time zones, to networking, no random values, nothing. It's architecture neutral, it's portable, it's secure. Again, because it's isolated, there's, by definition, there is no access to anything, file systems, there's no way to run viruses or anything like that, unless there is issue in virtual machine itself. And for developers, there's another good feature actually. You can easily recover from some issue. It's very often if something happened on your production server, and yeah, you see logs, you have final stack trace. You maybe see the input values, but how exactly these input values produce that stack trace? It's impossible to guess. It's really hard to guess. And this Ethereum virtual machine is blockchain. You can always reproduce the same operation, same logic. Again, because it's guaranteed by blockchain. It's ordered set of instructions. So you can debug everything easily. And you can build some fault-tolerant systems using that, because if something crashed in one machine, you can start from the moment before the crash in another machine. So you can have different machines connected together somehow and executing the same code maybe, and basically how blockchain works, how EVM works. So every machine, every node executes the same code. And yeah, I heard this issue actually in some conference like half a year ago. There is some initiative, I think from Microsoft. They're trying to make a virtual machine like real virtual machine to run Windows probably, to be reproducible, because for cloud environment, they want to make the fault-tolerant cloud systems. So you deploy your application into virtual machines on 2 different servers, and if one of them crashed, you should continue from another one. And it's super expensive, and it works, they say it in some situations, but again, because of random values, encryption, or anything like that, it does work for all applications, and I think it does work for most applications. It will work for some limited set of applications, and I'm not sure that it will be possible to run just ordinary, arbitrary operation system in that virtual machine. But you can do that on Ethereum virtual machine. And yeah, actually speaking about Ethereum virtual machine, that's some kind of promotion. We at ETC Dev, we develop a new implementation of Ethereum virtual machine. Same specification, full compatible with Ethereum, ETH, all these Ethereum clones. It's flexible, but it's standalone application. You can use it with blockchain or without blockchain, just to execute the smart contracts. Yeah, it's open source, attached to license, so yeah, you can take it and try it. You can use it for development, for like replacement for tester PC or anything. And we're trying to optimize it for IoT, for low-power devices, so at least Raspberry Pi. I mean, it works for Raspberry Pi already, but it's just too slow. For blockchain, it's slow on these kind of devices because you know all these problems with scale. So now speaking about IT, what exactly can be, what exactly IT can get from blockchain? Okay, that's good. You got EVM. So it fixes hardware differences, probably. So that's what was proposed by JVM initially, Java Virtual Machine. So developers shouldn't care about underlying hardware. You develop in one operation system and deploy it on another operation system. And for IT, it's even more important because you don't want to develop on Raspberry Pi. Yeah, it's a powerful device, but it doesn't have enough power to run your IDE and everything, compilers. So you want to use some powerful MacBook and deploy to some low power devices, which is hard because you need to compile for target platform, or you can compile for target platform as EVM and deploy everywhere. So yeah, the developer can use his operation system, which he's comfortable to work on, and deploy to another one, where it just works. But maybe it's not the whole point. Why really why people use blockchain? That's technical conference, so I guess, I mean, like in another conference it would be, I don't know, like you can run ICO or something. But, so you have really slow database, right? So why we use blockchain? It's super slow, extremely slow. There is some, I think Vitalik said somewhere that it was like, he measured it. It's a million times slower than Amazon AWS. So we're using something that million times slower than Amazon. Why? And yeah, it's compared to database and to VM, it's million times here, million times here. I guess you need to multiply them, so it's trillion times more expensive than Amazon. Why? Why paying this high price? For what exactly? Anyone? Okay, in my opinion, it's decentralization. That's the cost of execution you cut without any central party. That's why you pay trillion times more for that stuff. But how it can be applied to IoT? What kind of centralization IoT, right? Like it's I don't know. It's a big question, but really, it's centralized. It's pretty centralized. I just took some. It's like 2 weeks ago, some post in Twitter. But there are a lot of them. If you look around, there are a lot of people saying like, okay, that's post. If you don't see it, so basically, Bobby Lee he bought some IoT device in 2016, and it doesn't work anymore because company went out of business, and so the central server doesn't work, and he has a useless device now. Another example. So I have these lights from Philips. It's very nice. You have this light switch. You can bring it with you anywhere in the room, and you have lights, like, yeah, usual light bulbs. But also you need to have this central server. You see these arrows, this, I don't know, kind of Raspberry Pi maybe inside, I don't know what exactly. You need to have this device, a central server in your house, just to manage your lights. I don't know, it's stupid. Why I can't just switch on lights directly? Why needs a central server to switch on and switch off my lights? This kind of centralization also. It does make sense. And also, again, like 2 weeks ago, there is a post on Hacker News about Tesla engineer, ex-Tesla engineer, and he gave a lot of examples how Tesla worked and so on. And there's example of that from his experience. He spent some time on fixing some issues on their central server, and for about an hour, all these Tesla cars on the road, they didn't really work. I mean, all this automation didn't work because there was issue on the central server, and I was kind of worried. Yeah, I don't have Tesla, but I now want just to have a car with physical key and everything, because if someone got access to central server and can crash your car or stop your car or everything, I don't know, it's dangerous. And it's common architecture for all IoT devices currently. I mean, there you see there's a picture from some documentation of Amazon AWS. That's proposed architecture for IoT. You have devices on one side, then you send everything to Amazon data centers. They provide services for this stuff, some APIs. It's designed for this. So, and then you can analyze, do whatever you want, make some decisions based on this. And I believe these Philips light bulbs, they send something to central server. So when I switch on lights, it probably goes to Amazon. Amazon makes decision, and my lights went on. I don't know if that's true. That's really stupid. But that's how it works. It's a common design architecture for IoT currently. And now look at another picture. I took it from Aliexpress, which is famous Chinese website. People know about it. Yeah, kind of Amazon. Anyway, so you can buy this HD camera from Aliexpress for less than $5. So it costs nothing, basically. But really, you need to transfer all this by current design. You need to transfer all this video from your IoT device to central server for processing. That's how it works usually. So let's imagine you have an application that analyzes some traffic, people on this place, or cars in a road. So if you're going to send all this information, all this data, video, HD video, to central server, how much it's going to cost you? I don't know. If you got a good discount from T-Mobile, AT&T, maybe $20 a month, maybe $10. But it's more expensive than hardware itself. So you have powerful hardware, but you send everything to a server. And in fact, this example about analyzing traffic and people, it's an actual company in Miami, Florida, called AdMobilize. They do exactly this, but they're using Raspberry Pi, of course, for processing. So they have camera. They basically analytics company for billboards. So they give numbers for advertisers, how many people saw the advertisement by analyzing how many cars drove through this billboard. So, but they do analysis on Raspberry Pi itself and send just final numbers like once a minute to a central server, not the video itself. So Raspberry Pi is powerful enough to do all this processing. So yeah, there's another architecture actually. This one from Microsoft Azure documentation. But basically Google, Microsoft, and Amazon, they have this same ideas, same architecture decisions. They want to sell you cloud, whatever. So the another design architecture, you have something in the middle called edge device for pre-processing of your information you got from sensors, and then anyway send to central server for final decisions. So anything. So this is kind of centralization, which can be a problem. Yeah, like if a business that sold you this IoT device went out of business, your device stopped to work. That's a problem. But if you have only blockchain, it will continue to work even if there is nobody supporting it anymore. If business was bought or stopped, got bankrupt, whatever. You have a smart code blockchain where it will continue to work. And yeah, Tesla example. I'm worried that if everything will be centralized in this way, I don't know, government or criminals can get control over it and do whatever they want. And I don't know, maybe for good, maybe for evil. So as I said, what EVM can exactly solve. It's hard to write code for different hardware and different operation systems. And why exactly lead to centralization? So for developer, it's easy to write some super simple code, deploy into IoT device, and then write this complex software and deploy to Amazon, to some cloud solution, and do all the work on this central server instead of end-user device. With EVM, at least you can move some part of this execution to end-user device, to IoT itself. And it's better hardware utilization also. And also security, a lot of talks about security actually, and for IoT. I mean, there are a lot of attacks and everything. So again, for developer, it's much easier to outsource security to central server. It's hard to control devices on user side and hard to protect them. And yeah, it requires a lot of work. So it's much easier just to say, yeah, it's insecure device. Everything will be secured on our central server. Blockchain provides some security, not privacy, but security. It provides also privacy, but for IT it's too expensive sometimes if you want to encrypt everything. But you can sign transactions and authenticate some operations and so on. So it's more secure than no security at all. And it gives you some components for making your applications more secure. Again, using smart contracts. Who has a right to make this operation? Who has a right to open a door on some reaction or switch lights on, for example? You can make some rules, like, I don't know, switch off the lights during night and don't allow your kids to switch them on, for example. And also, yeah, updates. It's another part about hardware and security. All the software IoT software becomes unupdated for years and insecure, and because it's really hard to make this all updates. So it's much easier to make updates on central server. I mean, you start to make some software for your users, and you want to release it as soon as it's ready. So it's like some basic version. So you started to sell like from first versions and then continue development just on central server. That again leads to centralization. With smart contracts, it's more or less possible to update. At least there is a way. So smart contracts itself, blockchain itself, is against these updates. But anyway, there is a way to make these updates because there is signatures, there's authorization, authentication for these kind of updates, these kind of operations. So you can do that in a secure way for IoT. So how we see this? Basically replacement of this edge device with some IoT devices maybe. And maybe, when I was speaking about blockchain, I didn't mean this public blockchain. As I said initially, it's not about Ethereum ETH or Ethereum ETC. It's about blockchain in general, and maybe not even blockchain itself, but EVM. So it can be some private network, Ethereum-based private network, maybe not Ethereum-based because there is other protocols for IoT, much faster, and they are not encrypted, not secure, but they drill fast and more optimal for small devices. So you can use these protocols. Anyway, some isolated blockchain maybe sidechain of public blockchain if you want to make some atomic transactions between blockchain, make some payments for your lights maybe, whatever. And yeah, for your private chain, you can't use proof of work because it's too expensive for this stuff. So yeah, it's going to be some trusted environment probably. And for your home, you just trust your devices that you put on your house. Why not? And so for some of the devices, really for light bulbs or switch, yeah, for switch is a good example. You don't really want to run a full node on that device. There is no reason for that, but it can have enough power to send transaction. So basically connect to a network, send transaction, like switch on the lights, And a smart contract deployed somewhere on another device can make the decision not only lights, but there can be more complicated logic in your house. How lights switched on in which order. There can be many things implemented this way in smart contract. You just need to send transaction initially and then deploy different smart contracts to your network, your private network. And it can also have EVM running and blockchain running on a separate set of machines, but not one, maybe few of them, and maybe integrated. So basically, like this, you have some initiators, some sensors in one side, which send transactions. You have set of nodes, mini blockchain, that run smart contracts and make some decisions based on these events. And there are some devices which makes decisions based on these smart contract events. That can be one device, it can be separate devices. It's not necessary to have everything on one. If you have a powerful device like Raspberry Pi, you can run everything on Raspberry Pi, connect them to each other. And again, it will be fault tolerant. There will be no central point, no central server that can destroy and stop everything. So it can be used for some business needs. Again, you can control some logic in your factory on business when doors are opened and who can access something and who can switch on lights. Yeah, lights, it's a bad example probably. You can use it for your home. Basically, there could be a provider which makes all these simple nodes, and we have them actually for Bitcoin currently. There is few providers of some Bitcoin nodes based on Raspberry Pi. So there is could be something based on Raspberry Pi that you just buy, Best Buy, connect to each other, and it just works. You don't care how exactly it's technically it's implemented. Just use blockchain or not. But for developer, it would be much easier to use the same environment, same infrastructure, and without caring about any central servers. You just write some smart contracts that could be provided for different smart contracts to make this connection between all your devices in your house, and just unified protocol for communication between devices in your home, your house, or maybe in your car. And speaking about car, the example about insurance was 2 cars crashed, some accident, and some payment and everything. Yeah, it's kind of complicated. But what cars may really want, these autonomous cars, like in Tesla maybe. They want to make decision on a parking spot. It's a super simple decision. Who takes which parking spot? And you don't want to use some Amazon AWS server for this decision. It's just stupid. You have a call to some server somewhere just to make decision, like to find a free parking spot. Why? You can use some small blockchain for this geographical area and call this send transaction. I want to get a parking spot and listen for an event. If 2 cars come to this parking space, they can make this decision without any central server. And this kind of settlement, it's not financial, it's not digital assets, but it's still decision made between machines. And I think these machines, robotics, autonomous cars, they need some trusted or trustless environment to make decisions between them without human involvement in any way. Just to write smart contracts and make this logic based on smart contracts. Thank you. And if you have any questions, I will be happy to discuss all these things about IT. And also there is my email, Twitter. If you want to ask something later, if you have some thoughts, please send me an email. There's also our company in CDEV team, which is working on Ethereum Classic. And if you want to join the Ethereum Classic community, there is join.etc.tech website. Any questions? So honestly, we just researching this. We got a couple of guys with experience with IT, and we see that it can be used this way. But again, we try to talk to some IT companies, and they actually don't know how they can use IoT too. So everyone wants to use IoT, everyone wants to use blockchain, but nobody knows what's really blockchain and what is really IoT. So there's no practical applications yet. So it's more like research. As I said, it's I just want to discuss this. It's some controversial topic, and to think like that you can run something different, not just ICO or digital assets on blockchain. There is different fields, different domains. You can write something for IoT, and yeah, it will take some time before we'll get some practical application. Same as for digital assets. Except with Akiris, we don't have anything yet.
Question. Do you have clients that you've been working with this on right now?
We have some interest, but it's, yeah, as I said, no, nothing practical yet. So we're trying to figure out how it can work. And yeah, the problem actually, all these low-power devices, they're just too slow, too small. Like Raspberry Pi, it's good, but nobody really uses it for small devices. For, you know, light bulbs and everything, they use really low-power devices. You can use them to send transactions. It can be fixed on hardware level. They, you know, the companies which make this hardware, they want to sell more powerful device because more profits for them. But yeah, it is still research for all parties anyway.
Would it be reliant upon affecting the technology of the hardware, like of the actual a pool cleaner, for example? Would it impact and affect what's currently in that product, or would it be able to embrace that?
I'm not sure what you mean. Like replacing existing code in the device with.
Sure. I mean, if it's already IoT enabled.
I don't. Yeah. Another question. What's IoT? Because for some people, IoT it could be like a big device. Like, you know, like trains is IoT too. They have huge devices which. Some CPU inside, which makes some decisions and gathering all these sensors, and it's very powerful actually, and it's huge. And yeah, you can run it on these devices, but they just use software which was written, I know, 15 years ago, and they're happy at this moment with this kind of software. So it's more about future at this moment. You can probably replace that, but it will take some time. So we researching and yeah. Mm-hmm.
What do you see as the most profitable use case of that? Like, what do you think is going to be the big, solution?
I don't know, but yeah, it definitely changes the market, like landscape, because I mean, like compared to blockchain, first of all, like it's not ICOs and digital assets. I don't know, but like making some automation for your home, some, I don't know, kits to build your automation or businesses, that. I don't know, there could be a lot of businesses around it. I don't know. But we'll see. There's nothing at this moment in IoT itself. There's nothing at this moment unrelated to blockchain. So a lot of businesses trying to figure out what to do with IoT. If you don't have any questions, then thank you.